Okay, so let's see. We did not have homework for today yet, right? We are still working on our startup for object-oriented language. So what we talked about last time was the idea of how object-oriented languages are actually put together. First of all, everybody can see my screen. Everybody can hear me. Let's make sure that's the case first before I babble on.
Yeah.
Sí, señor.
All right.
Is the current code up to date on GitHub?
Maybe. I think the answer is yes. Yep. Well, actually, hold on. $470. Oh, wait, we just called it this guy. Yeah, it's up to date.
Thank you.
Okay, so back to this idea. We were talking about classes in terms of environments last time, and I want to show that to you in maybe a little bit different context. So if we, because I want us to think about classes as a part of a larger solution. So if we think about Java, for example, actually, let me get a new slide. Or pick your favorite modern language, doesn't really matter. You know, we typically have, if I just kind of draw a picture of how I typically will make a class, we have one class that I usually call driver. All right. And then we have some other classes that do something else. So I'll use the example, I think from that we talked about last time. So I have the idea of a room, and I have the idea of an exit, and I had the idea of an inhabitant. And inhabitant was actually an abstract class. So off of that, I actually had a class for player and a class for NPC. Something along those lines. All right, so in this little model here, we actually have a total of 6 total classes, right? So we have 6 total classes, and these classes are then used inside of driver. So we create instances of room. Instances of rooms, exits, players, NPCs, etc. Those things happen inside of driver, and that's where our actual program, let's say, lives. All right, so in a language like Java, what ends up happening is we have that concept that all programs begin and end with main. So typically we put that public static void main string array args thing inside of driver, so that when we hit the play button in Eclipse or whatever program we're running, it ultimately goes to the main method and starts doing whatever this guy says. And he's using these objects as building blocks. Okay, so he's using these objects as building blocks to put the thing together. So what we're learning how to build right now is this piece, or this piece, or this piece, so on and so forth. All right, so where an object has a parent class, and we'll go ahead and draw that parent class in here. I'll do this. So we have a concept of an object, and I'll make this guy red like this. So something like this, where all of these, let's kind of keep it like this. So we have a top level class called object. From that, we have a class called inhabitant, a class called room, a class called exit. Room and exit stop right there, but actually inhabitant is further specialized by going down to player and NPC. Okay, by going to player and NPC. So this is the model we're trying to build. So whenever we build a class, and let's go look at how we connected that in our Dr. Racket. So we have the concept of an empty object. So this is that top level object. So what we're doing right here is this piece right here. That's an object that effectively does nothing for all intents and purposes for us right now. Then we're having the idea, the concept of a class constructor, okay? Where a class is a base class. It has a list of fields. So if we think back to our Java connection here, when we built inhabitant, an inhabitant maybe had a name. It had a number of hit points, a number of, a strength value, whatever it was. And then players and NPCs further specialize themselves. But let's say inhabitants had names and hit points. A room had a name, a description, and a list of exits, where an exit has a name and a room that it links to. Something along those lines we could say maybe makes some sense. All right, so each of these classes had a collection of fields associated with it. It had a constructor. Right now, I mean, we could potentially write multiple constructors in Java. Right now, we're just going to support a single constructor. So it had a constructor that was to initialize those fields, let's say, even though they potentially could do more than that. But let's just say that's the job of a constructor. And then it had a list of methods, things that these guys can do. So, you know, a player maybe could attack, an NPC could maybe defend, a room could find an exit. They could do, you know, a bunch of other things that was, you know, things that were related to the fields of this particular object. So when we come back in here, we see this is our constructor for a class that's built in terms of an empty object at the highest level. So this is a lambda that's going to take in who is my base class, you know, who is my parent, the list of fields. These are the attributes we're going to keep track of, the list of values that should be linked to those fields, and then a list of methods, which we're pretending don't exist yet. All right. And then what we did is we went ahead and we did a letrec so that we could effectively merge our list of fields and our list of values together. So we just wrote a create pairs for scope, and this guy goes through and just creates a list of two lists where each field had its value associated with it. Okay, so that's what this function does. And this guy right here, that's what that guy does. Then we created this idea of a global environment. And that's where we were connected over here, where we said, okay, when I have a class like this, we have our class has a global environment associated with it. And what's in that global environment? Typically, it's our collection of fields, right? Those are the things that are the part of the environment of a class. And then we have some more local environments within a class when methods are running. They create a more local environment so that we can ultimately have a stack of scopes where we always try to resolve a value to its most local definition. All right, so inside of our class here, we're creating a local variable called the global environment. And the global environment is going to be a list containing create pairs for scope, list of fields, list of values. So it's going to be our initial name value pairs for our fields. And it's going to have those guys as a list. Okay, so this is going to, at the end of the first time through, this will be our global environment will be a list containing a list of two lists. That list of two lists is the top level scope. That's our most local scope right now. Okay, so our global environment happens to be, or it's going to work like a stack of scopes. Okay. Now, we could write our environment to an environment situation for that. And we might end up doing that. I just want to go a little bit farther before we do that. So for right now, we're just going to remember that our global environment, and here I'll just put a note here. Global env is a list of scopes, where a scope is a list of name value pairs. These are two lists. All right, that's what our global environment is going to be, and that is a local variable that belongs to a class. And if I connect that back to our picture here, this guy has a global environment that knows about all of the fields of inhabitant. This guy is a global environment that knows about all the fields of player, knows all the fields of NPC, of rooms, of exits. So each one of these individual classes has its own global environment. So when we say global environment there, we're actually talking about, really, it's a local environment to a class. But right now our world is classes, but now when we see how classes are actually used inside of a language like Java, we say that, oh, well, we have this one class driver that we specifically built to be the starting point for our program. So this class typically does not behave like our other classes, right? We don't usually put a whole bunch of fields and stuff like that in there because we're not using that class as a means of representing data. We're using that class as our mechanism for running our program. All right, so you can almost say that that's kind of a hack. It's like, oh, well, where does our program start? We got 5 or 6 different objects here. Where do we actually start? Well, we start with main. So we got to put main somewhere. As the language designer, they had to decide, well, fine, where do we put main? Do we make this like specialized file, maybe called main.java? And what main.java does is it just holds your main method, and anything it says to do in there, it uses the surrounding objects. Well, sure, they could have done that. They could have created a special kind of, pod just for starting and stopping a program. Instead, they said, well, why don't we just leverage our existing class and say that the class that has main in it is the one that gets run, because all programs begin and end with main. And that's been something that's existed as we've gone through the history of languages. It started in C, probably started before C, but we've kept adopting that idea of a main method, and that's where everything begins and ends. All right. So this was a decision that the language designers made when they decided, oh, we're going to kind of hijack a class and use it for running our program by allowing them to put a very special method in there that has to be written in a very specific way so that we know what to call. When the program starts, when the Java virtual machine starts running, it's going to look at your classes and call the main method it finds. All right, that's how that guy knows how to run. All right, but each of these guys has its own variable environment in it. And then there could be a more global variable environment. We've seen this before through like static methods, where we maybe create something at the top level and have it shared between, a lot of times I'll call that like core or something like that, where it has a whole bunch of static fields in it, and it's a single class that has a whole bunch of data that can be shared across all your other classes. Right now, we're going to keep everything fairly compartmentalized and only add new features as we need to. That's partly just so we can understand object-oriented language design, and also for time. All right, but we want to think about each of these guys as being a collection of scopes, where there's a top-level environment that has the fields, and then there are local environments that live and die as this guy's methods are being called. Okay, so we need to have a way of representing that. And that's what we're doing here with our global environment being a list of scopes, where scope is a list of name value pairs. Okay, right now we don't actually have facilities for methods yet. So the idea is when we eventually call one of our methods, however that ends up working, what's going to happen is we will push a new scope onto our global environment, and that will be the most local scope that that method will operate under. And then we'll have to have a resolve variable that operates off of those scopes, which we might write or we might just talk about abstractly. Okay, so this is what our letrec creates, these two variables. One's a method that gets used by the other one. So really the variable we care about here is global env, which is what's left over. So this is the environment in which anything inside this class happens. All right. So then what are we doing? As part of our constructor for our class, we're creating a list, class, base class, the global environment, and then the list of methods. So this guy ends up being again, list of methods is currently empty, but this guy ends up being a data structure for holding the components of a class, where our fields live inside of global environment. Super is related to our base class. List of methods would be presumably a list of lambdas that we can call later on. Methods inside of classes are usually named. So frankly, our list of methods probably will end up living inside of the global environment. All right, so what's down here, we decided, okay, well, we want to create a person, the concept of a person. And a person is going to have a list of fields and a list of values for those fields. So this is us saying, I want to create a specialized class. And that's going to have a list of fields and a list of field values. So I'm going to call my constructor for a class, passing it my parent, which is the empty object. That's this thing right here. If I'm creating this class right here, his parent is the empty object. If I were creating this class right here, his parent would be inhabitant, whose parent would be object. Okay, so we're not handling this yet, although our code already will work for that. But our example right now, we're creating this idea, what I call a person. So we're creating this idea of a person. And here, let me just sweep this other stuff over here. So we're creating this model right here where a person is being built in terms of an empty object. Person has his fields and their corresponding values. So this is kind of our constructor we're building into our person class. And we build a person class in terms of who his parent is, what his fields are, what the corresponding values that should be initialized for those fields into the initial global environment, and then a list of methods. And these methods are probably going to come in the form of method names and method bodies. So maybe something similar to field names and field values, something like that when we get to it. All right, so this is our constructor for a person object. So now I can create a person, P1, and he's going to be a person that is automatically built off the empty object. So I don't have to pass that in. If we want to support our own version of inheritance, we would have to pass in who the parent is here. So we could do that. But let's just leave it alone for right now. Right now, we're assuming that all of our objects inherit from the top level empty object. So I'm saying, okay, a person has a first name, a last name, and age. And here are the values that should be associated in the global environment for that guy. Okay, when we printed out P1 and P2, we saw that these guys were collections that now had a first name Mike, a last name Littman, and age 21. And the other one had a collection, first name Dave, last name Smith, age 18. This is the global environment for that particular object, which is a list of scopes, where this is a single scope, a list of two lists. Okay, but notice that each of these classes has their own list of two lists. All right, so now we have P1. Now we might want to get stuff from P1. So now we think about what are some things that we want to have for our objects. Well, sometimes we want to be able to get the name or get the value or so maybe get a field given its name. So one thing we can say is, well, because we're making an assumption about how our constructors work, where we're always passing it, here's my fields and here's the values I want you to marry to those, rather than us having the flexibility of writing our own constructors. It's just the design decision we're making, and we're just saying, hey, constructors are made for linking fields to values. That's what they do. If you want to do some other setup stuff, that's fine, include it in a method. Just that's going to have its own constraints associated with it, but it's a reasonable enough thing for the language designer to say that they're going to do. Okay, so now we want to be able to, now that we have instances of our object like P1 and P2, these guys should be able to do things like maybe get the value associated with certain fields. Okay, so maybe I want to be able to say something like P1 get field, and maybe pass this guy F name, something like that. And maybe for P1, I want that to give me Mike. And for P2, I want that to give me Dave, something like that. All right. The way this is set up, and it's the reason why I showed you Objective C the other day, is this is something called message passing. So let's go back to this guy and ask, how are members of a class called? For us, actually, it's called, let's say, accessed. Where members or anything that is a member of a class, fields, constructors, methods, for our particular language we're building, the only thing we can access is, let's say, methods, even though they don't exist yet. But the question is generally speaking, when we're dealing with objects, how are members of a class accessed? Well, they're accessed through an instance of the class is notified of a desired action. We can think of this like a message being passed to a particular instance, and that instance reads the message and responds, and I'll say potentially using some parameters that were passed along with the message. Okay, something along those lines. So we might say P1 get F name. Maybe we decide that all of our classes come with built-in getters where we can get the value of something in the fields. I know this kind of takes some of our decision-making away that Java gives us, where we can have getters and setters for specific things, but maybe we decide that, you know what, all objects will allow us to get the value of any of those fields. And that's going to be a built-in method that all of our classes automatically have. Okay, so now we need to think about, well, how does this ultimately work? When a instance of a class is sent a message, in this case, the message is get. And in this case, get requires one parameter, so we're also going to pass in the parameters for that guy, which is F name. So this is who, this is the message, and then this is 0 or more params. So we can say that that is the cadence for calling members of a class. It's done through something called a message passing interface. Okay, so we send this message to this guy, potentially with some parameters, and he responds to it. That's how we use classes. Okay, in Java, we would have said p1.get fname, something like that. Okay, so we're going to build this into our environment here. So we need to have the ability of looking something up inside of our global environment, because again, we are one of these guys. We need him to be self-contained. So I need to now be able to take like my P1 and send him a message. Okay, so P1 needs to be able to be used as a recipient of a message. P1 effectively is a function call. All right. So we're gonna have to have a the idea of maybe called send P1 this message with this parameter. So we're gonna have to have a send function that's built into our language that allows us to send a message to a class. So we might say define send. Actually, why don't we call it send message to be really explicit about it? Send message. And this guy will be a lambda that takes in a who the message is going to, a what the message is, and a list of params. That's what's going to get sent to our message. Okay, so with that in mind, we're actually saying send message, this guy, and then we're sending it the list containing our parameter. Name of the function is send message. Who's getting it is this class. Who's what message are we sending to the class? We're sending get field to that class. And then we're passing it these parameters. Okay, so we need this function send message. Where is it at? Send message to be able to look up something in this guy. What are we looking up? The thing that is associated with that message. So maybe we call this the message. And then list of params. So we need to be able to, when we ask this guy, when we send him this message, the expectation is he will look something up in his global environment. Okay, and his global environment contains all of his fields and all of his methods. All right, so we're going to say that the baseline for a class is also going to have some built-in methods like get, all right, which gets a field name. But now if we say that all classes get field names, if all classes have, here, let me ask it in a slide. If all classes have the ability to get the value associated with a field, where do we implement that ability? Is it in the specialized class, or is it in the base class? In this case, empty object. What do you think and why? 100% of objects are going to have the ability for us to ask him for his fields. We're effectively presuming that all fields are private.
I would say the base.
Okay. So what you want to do is you're going to say that it is this dude here that knows how to get the value of a field. This guy inherits that, right? Because his base class is an object, which already has that ability. So he's going to get that ability from an object, from an empty object. So if we go back to the idea of an empty object here, an empty object is right now just a list of an empty object, but really this is what was produced by our class constructor. Isn't an empty object a class? Isn't this guy a class? Go back to my picture here. Is this guy a class? Sure. This guy's a class, right? So both of these are classes. So now we kind of have a chicken or the egg type problem. If this guy is built on top of object, who is this guy built on top of? Is there anything above this?
Oh,
Who?
no.
That sounded like an incredibly confident no. I expect that from Clancy, not you, Noah. That was Noah, right? That answered that?
Si, senor.
See, that had more confidence. All right, so and this becomes kind of the interesting caveat of object-oriented language design. It's that right now, this guy is being built in terms of this guy, but this guy is one of these guys. An empty object is a class. That's what he is. So I'm going to take this guy here, and I'm going to put him after this. So now when we build a person is going to, when we build him as a class, he's going to take in that base class, which is an empty object. That's our constructor for empty object. That's what this guy is taking in. He is taking in the result of calling empty object, where empty object is a lambda that takes no parameters and just returns list of empty object. When really we want an empty object to be a class, right? That's the kind of animal he is. He is a class. So we want to build, so instead of this guy just spitting out a list called empty object, we instead want to go ahead and call our class constructor, passing it. Now this guy expects several things. It expects, I'm going to put a question mark there for a second. So he expects the base class. He expects a list of fields. So we're going to give him nothing for his list of fields. Also nothing for the corresponding list of values. So a generic object doesn't have fields or values in our world right now. We could certainly put some stuff in here if we decide that empty objects need to have some stuff. But for right now, we'll leave it empty. All right, so it's a list of fields, list of values, and a list of methods. Okay, so really an empty object is a class that has nothing in it, but it still is a class. So then the question here is who is the parent? Who's the parent of an empty object? And I think Noah kind of said, no, there is no parent with a lot of confidence, right? And that's true. There isn't a parent. This is the end of the line. This is when we have to stop searching. If you're looking for a field name and you've checked, if I've looked for a field name in player, I don't find it there. Then I check inhabitant. I don't find it there. I check object. I don't find it there. Now I'm done. I'm out of options. I've hit the roof for places I can check. So I have to have some way of representing the nothing class. Okay, the class that is nothing, null value, whatever, something like that. I don't know if Scheme has a null built into it. I would assume maybe. Oh, I didn't finish dividing this. Just put some parentheses in here. Oh, expects the body. Here. He's not hurting anybody right now. All right, so we did change our class to now take in a base class. So we pass it an empty object. All right, I'm thinking this null is not working. What is the null value? I guess we can pass it the empty list because we can test that against null. So an empty object is a class built with no parent, no fields, no associated values, no methods. And this is just what we decided is our representation for no parent. In fact, if we want, we can actually just put no parent in here and just say that's the base class, and that'll be our test. So when we ask is who's the parent, and we ask is the parent null, really what we're going to ask is the parent of this guy equal to no parent? If it's equal to no parent, then we're done. That's our special case. That's what gets us to the top of this mountain. I check here, then I check my parent. I check here. If I don't find that, I'm going to try to check my parent, but he doesn't have a parent. How do we know? Because his parent is labeled as no parent. So somewhere we have to have a beginning. This is our starting point for all object-oriented programming languages. We have to have this top level class. All right, so we've redefined empty object to actually be a real life class. He's just a class with no parent, no fields, no values, no methods. That's what he is right now. All right, so now when I build a person, I can build a person in terms of that. So here's a person. It's going to take in a list of fields, a list of values. He's built on top of the empty object constructor, which is a class. That'll be a real life class. All right, so notice here now, I'm only printing out P2, that's fine. So P2 is the parent is that guy. I'm storing the entire class representation of my parent. I'm a class, no parent, and there's my global environment. It's a list containing nothing. So there's my global environment, and there's my list of methods. So here's a list containing nothing. This is my global environment. So a list containing a single scope that has nothing in it, because there has to be a top level global scope. All right. And he's built on top of this class, which is then a list. Here's his global environment. And then here is his list of methods right now. Now, what we're going to do is we're going to, as Noah pointed out, we're going to say that it's actually empty objects that are going to have a get function. Okay. Now we can write this in, I'm going to try to stay consistent with what we did here, where we have our list of field names and our list of values. We already have a way of merging those guys together, creating pairs for scopes with our list of fields and our list of values. So rather than this guy just taking a list of methods, I'm going to have him take in a list of method names and a list of method values. So similarly, how we had our list of our field names and our list of our field values. In fact, let's call this field names, and we'll call this list of field values, and we'll have to update those in our code down here. List of field names, list of field values. Okay, so now we're not just doing that. We're now going to also add in a list of method names and a list of method values. Now, method names and their associated values, which are going to be lambdas, these guys are just variable names like anything else, right? Create another slide. Where do we store our methods? If fields have names and associated values, where do we put them? So where are we putting our fields and their associated values right now?
Our environment.
Our environment, good. So we're putting it in our global environment. Okay. If methods have names and associated values, let's say probably lambdas, where should we put them? So where do you think we should put our methods? Do we need a separate place, or do all these things go in our global environment?
I would say in the global environment.
Yeah, our global environment is a collection of all the stuff we know about. We might have an integer named a and have it equal to 5. We might also have a function named factorial and have it equal to a lambda, right? They're still just name value pairs, just the values look a little bit more complex. All right. So this guy is our constructor for class is now going to take in a list of field names, a list of field values, a list of method names, and a list of method values. And he's going to presumably fill up our global environment with all those things. All right. So what that means here is that for my empty object, I've decided that this guy gets, he has no fields, but he will have a method. So this is my list of fields. This is field names. This is my list of field values. This is my list of method names. This is my list of method values. So we're going to call this guy, maybe we have a function called get. Let's call it get value. And get value will have a value that is a lambda that takes in a var name. I'm going to kick this down. Let's see, is there a good way to... Well, for right now, I'm just going to say it's a lambda that takes in a var name and boils down to the empty list. Actually, let's just have it boil down to need logic here for right now. All right, so that's what an empty object is now. No field names, no field values, one method name, and here's the associated value. All right, and this will work. It's just a useless method. You pass it a variable name and it'll just spit out need logic here over and over again. All right, but we're not even caring about how do we call that. What I want to know is how do we update this code to add my method names and associated values to my global environment. I'll go ahead and send this. So I've pushed origin. So take a couple of minutes. Now that you have my current version of code, make sure you still have that current version of code. Yep. And update our class constructor to now be able to get my method names and corresponding values also into the global environment. Make sense what I'm asking? All right, so take about 5 or 6 minutes and try to update this code to now work for its updated constructor. So let's take a look here. So now we're taking in our list of method names and our list of method values. And we ultimately already have a function called create pairs for scope, right? That takes in a list of names and the corresponding list of values, and it'll give us those two lists. Right now, we're passing that guy our list of field names and our list of field values. Now, what is your suggestion for updating this code to also allow us to have our method names and method values embedded in there? Because our total number of things we need to remember is the length of field names plus the length of method names, correct? That's the total number of name value pairs we're going to have. So how do we create a single global environment with all those things in it? Anybody come up with a solution for this?
Could we just append another list doing the same thing? Create pairs is, well, no, at the beginning. So the whole list of create pairs for scope. Could we just, that entire list,
Oh, I see what you're
do
saying.
that with like method names and method values and just append those two large lists together?
You absolutely could. I think it might be easier to just start off by appending your list of field names with your list of field method names,
Okay.
and similarly do it, but it's ultimately going to have the same result, is what you said.
Okay. Yeah.
You could do it beforehand or you can do it afterwards. So I'm going to append my list of names together and my list of values together. And that's the name value pairs. So now my global environment will be a combination of all my field names as well as my method names, along with the corresponding field values and corresponding method values. You do need to make sure you append these in the correct order, though. That way everything matches up. This is effectively a parallel array solution to things where I'm saying, look, I have a list of stuff here, and each element of this corresponds to one element of this. So this will create the two list for that. All right. And what she was suggesting is create an append out here and call create pairs on the list of method names and list of method values separately, and just append the two answers together. And that would work fine too. Ultimately, it'll create the same thing. This just has me calling my function once, just passing it beefier lists. Okay, so then in the body, I'm going to do the same thing I did before, so I don't need to do anything special there. So now when I'm creating an empty object, it's going to have no fields, but now it'll have a single method name, get value, and a corresponding function that goes with that. List of field values. Didn't I copy it? Oh, must not have. Let's see. It takes in a list of methods and a list of method names. Base class. So actually, this won't be methods anymore, because now all my stuff is contained in my global environment. So my class is going to be who is his parent and what is the environment in which he lives. Field names, field values. This is for person. He's expecting list of method names, list of method values. And I'm not adding anything for person yet. All right, so here is P1. P1 is a class whose parent is a class with no parent that has a list called, so this is its top level scope here. Wow, couple, yeah, that's it. Top level scope. And in this, it's going to have no fields, but it's going to have a variable that is get value, and a value that is a lambda. Now, actually, this value should be, I created it incorrectly here. This should not be a list of strings. This should be an actual lambda. So when I build my object here, this is a list containing elements. For my methods, the element it contains is not a quoted list. It is a actual real life lambda. Oh, hold on. I need to say list of this guy. So I'll create a list containing all of the values. So this will give me a lambda there. So now you see that his value is a get value, or the variable name is get value, and the value of that is an actual lambda. That's a function that I could call, okay? And then I have my global environment associated with my person class, which has, Dave Smith 18, that stuff. All right, so now inside of my global environment somewhere, in this case, just for my global, for my top level parent class, I now have methods. And I want to be able to call those methods. So I want to be able to do something like send message to P1 to, what did I call it? Get value. I want to send it the get value message. And the value I'm looking for is first name. So I'm passing it a list of parameters here. Okay, so this is how I ultimately want send message to work. So I'm going to have a function named send message. Now, send message, if we kind of draw it into our picture here. And let me do it in terms of what we've created on our screen. So I now have a person. And a person comes from object, or empty object, really. Okay, so, and objects have the, oh, I created two of them already. To get value. So one of the things objects know how to do is get value. Okay, and now this whole class here, we see what that class looks like. It looks like this thing. That whole class, this is a textual representation of what I have right here, where this guy has a, F name equals Dave, L name is equal to Smith, age is equal to 18. I think that's what all those values were. All right, so this whole thing is the global environment. This guy has a global environment that is this. This guy has a global environment that is this. When I send a message to person, send message, get value, F name, and what did I call this guy? I called this guy P2. Just steal it from my code here. So this was P2 that was built with that, just so we can connect the code to the picture. All right, so P2 creates this for me. That's what this guy does for me. All right, so this is the picture of what he actually makes. So now when I send a message to P2 to get the value, so this is a send message function, and this function takes in a class the message and the list of parameters. That's what he takes in. Does send message where does send message live? Is it on his own? Is it within the empty object? Is it within, in our case, I'll just give you the player object, player class, sorry. So where do we actually write send message? Where is it implemented and why?
Would we want it in the empty class so that all the other classes inherit it?
Okay, so maybe here, so all other classes inherit it. Okay. Not a bad idea, but here's the problem. If I put send message up here, which we could, right? Now I'm still going to ask the question. I'm going to move this guy off to the side. How do I ask? Well, how do I send a message to P1? As humans, we can look and say, oh, well, send messages right there. But we also know that P1 is a person that contains an object. So P1 is actually this thing. I'll go ahead and paste that in there just so we have a textual representation of this. So this is what P1 actually is. This is the picture it represents. So if we've hidden send message inside of object, which seems reasonable enough on the surface, it's like, hey, I want all of my objects to be able to receive messages. So I need to have that ability somewhere. But now if I've hidden it inside of object, how do I send a message to P2? Actually, why did I say P1 here? How do I send a message to P2? If his ability to send messages lives within him, how do I ever get to the object side of this? Because realistically, what are we trying to do? We're trying to send a message to a person. And we're going to look inside a person and say, hey, do you have a get value? The answer is no. So what are we going to do next? We're going to bounce up a level and check objects environment. And we'll find a get value in there. All that makes sense. But how do I start the process of calling send message? Send message has to be accessible to us, because what does send message ultimately accomplish? What does send message accomplish?
It sends a message.
As the name implies, right? It sends a message to who? To whom? What does that message actually do? It does send a message, you're right, but what is it actually accomplishing?
It's giving a command to our person object to return a certain value.
Okay, so let's think about it in terms of this picture. We're out at 25, correct?
Si, senor.
Okay, good. Timing's good then. All right, so let's assume that we have this picture. And so Noah's standing in front of me. All right, so Noah, you happen to be our instance of person here. All right. All right. So, see. So Noah ends up being our instance of person here. I need to somehow, if we're thinking about that programming languages allow us to solve problems in a similar way to how we solve them in real life, I need to somehow have the ability to send a message to Noah. Okay, so if I want to ask Noah in real life to do something, what do? I
You just-
say something out loud, right? An
Yeah.
external force acts upon the object that is Noah. I say, go and pick up the coffee mug, something like that. Now, Noah could be obstinate or something like that, but generally speaking, Noah would receive that message and he would respond to it, right? So is it fair to say, in the most general form, if we assume that Noah is is just one of our persons, so we'll call him Dave here in this case. So Dave is a pretty simple thing, right? Is it fair to say that the one way that I can communicate with an object is by giving it commands, sending it messages? But that has to happen from an external source. Otherwise, let's assume that Noah was standing there, and let's assume that I didn't have the ability to speak. No sign language, nothing like that. And we can complicate it, really. Let's just make it extreme. I can't speak, Noah can't hear. Okay, none of us can see, doesn't matter. So we're two objects sitting in the same room. I'm a ghostly apparition since I'm not represented on the screen here, but somebody's got to be trying to give the commands. Noah's just standing there, or Dave's just standing there waiting for a command, but with no facilities for getting him that command. So if I don't have a voice and Noah doesn't have the ability to listen, I can't get a command to him. Does that make some sense? So send message. Jeff not here. This is correct, since we need an external force to act upon objects. That is to say, a function that takes a class, a message, and a list of parameters. And that message is then applied to a class by resolving the message to its value. So what does this ultimately mean? Look up the variable name in the environment, and then applying that, in this case, method to the list of parameters that were passed in.
So
That
would this
makes
kind of fall into the category of like in C# when you have the includes at the top of the document?
No,
Would
this fits into this category. Me saying, so in Java, me saying something like p2 dot get value fname.
Okay.
This is how we send a message in Java. I'm sending the get value message to p2 given this parameter.
Okay.
So we're writing that same ability into our language, and we want to be able to accomplish that. Did I already write it in here? Oh yeah, right here. We want to be able to accomplish it this way. These two lines are equivalent. Does that make sense?
Yeah.
All right.
I'm still a little bit confused. So to get the communication between the two classes, would it be like P1 call send message, but we pass in P2?
Well, no, I had that written wrong up here before. It's it's P2. Said message is going to somehow is the homework, is going to somehow apply this message or send this message to this guy, in this case P2. And the message he's sending is get value. P2 is a person. So he's going to check his local environment first for that message. Does he find anything in there called get value? The answer is no. Nothing there is called get value. So he's then going to say, do I have any place else to look? Yes, I do. I have a more global scope. I can bounce up to my parents' scope because I have a parent. That is my parent. If I am this person class, if I'm this person, my parent is this whole guy here, which is a whole nother class. That class himself doesn't have a parent, but this top level class does have a parent. It's this dude. That's his parent. And that guy happens to have a value or a variable name, get value, which is associated with a lambda. That's what we have right here. Get value associated with a lambda. So the way this would resolve is we would send the message to this class. He would check locally here, not find it there, ask, do I have a parent? The answer is yes. So he would then go to his parent, check for it here. He would find it. It would give the value, which is a lambda. We would then apply that to first name and be able to look up this guy's variable F name, which is Dave. But let's say we were looking for get values like this. Then we would say, well, I didn't find it here. Is there any place else for me to look? No. So I'm done. Error message, couldn't find it, whatever. All right. So we're right back to where we were at a long time ago, where we now need to resolve environments. You know, we need to, we have our variable environment. We need to get a value out of it. And then you do something with the value. So our homework is to implement send message such that it allows us to get, well, we're going to say, get the value from a class for one of its fields. So, for example, this guy. All right, and you'll have to write the logic to accomplish look here first, don't find it there, look here, don't find it there, scream. But we know that all of our top level objects do have a get value because we wrote it that way. We wrote empty object to have a get value, which is a lambda. All right, but keep in mind that one piece you're going to have to fix is right now this lambda just returns need logic here. So this is part of homework right there. So you need to write part of homework there and then define send message. And then I'll just say homework here too. All right, makes sense? I'll push this code to GitHub. Now you have the most up-to-date version of that code. All right, questions, comments, concerns, bribes?
I actually do have another question.
Sure.
With the result of the code, can you like explain like the three nested lists within get value and lambda and A1? I'm kind of confused how get value is there, and I'm guessing A1 stands for something, but I'm not sure I understand how they got that.
Where are we? Oh, this guy right here?
Mm-hmm.
Yeah, that's just how scheme represents our, yeah, we didn't write that. That's how scheme represents a lambda. So notice here we passed in for our empty object, we passed in an actual lambda expression. That's not a list containing the word lambda. That's a real life lambda. That's a function. So scheme represented the value of that guy as this. That is a lambda that takes a single parameter. We got named it A1, even though we called it var name. And then the dot, dot, dot is the body of that function.
Okay,
This is how the scheme represents a lambda.
so get value and the lambda aren't related. They just happen to be next to each other in the same list.
Well, they are related because this is the variable name called get value, and this is its value, which is a function. So just like in Java, if I were to say p2.getValue, I want to find the function associated with the function name getValue. So getValue has a name, or getValue has a value, and that value is a lambda. I'm looking it up inside the variable environment. So right here, here is the first to list in my variable environment here. I have a variable named getValue whose value is this lambda. Just like I have a variable named first name whose value is Dave. I have a variable named lname whose value is Smith. I have a variable named getValue whose value is a function.
Okay, I think that makes sense.
But keep in mind, we didn't write this. This is how Scheme visually represents their lambdas.
Mm-hmm. So
We wrote this up here. So when we actually get the value out of here, we will have a real life lambda that we could pass one parameter to, and it'll do whatever we told it to do.
So is for lambda right there, is it taking in get value for the var name?
No, the var name would probably be f name.
Okay.
So if we look back here, see how I'm saying send message to P2. What's the message? I'm looking for the value of your thing called get value, which is a function. And I want you to pass that function this parameter.
Okay.
So it would take a list containing f name. We pop it out. You say, oh, you want the f name? I'll look up f name in my local environment, or at least I'll try. If I can't find it, I'll check more globally until I can get you an answer for f name. For P2,
Okay.
this should spit out ultimately, if we were resolving this, this would spit out Dave. Would be the answer for that one.
Okay. I think I'll have to study the code a little bit more, but I'll let you know if I'm still confused later.
Okay, no worries. All right, have a good one.
Adios, senor.